All right, so it's recording now. All right, so what I'm planning to do, we're going to go through and work out the test samples. And when you work these out, you need to do them on paper. Our first question would be something like 8 over 9 times 5 over 8. Now, if I look at this, I see that I can cross-simplify and reduce before. So those 8's are the greatest common factor of each. So then you multiply across the numerators, multiply across the denominators, and we get 1 times 5 is 5, 9 times 1 is 9. Okay. So your final answer for that would be 5/9. And for this particular problem, all you have to do is multiply across the numerator and the denominator. The second problem was also a multiplication problem, and we have, in this particular test, 2 over 9 times 7/10. Remember, for multiplying, you just go straight across numerators and denominators. If you see we have 2 and 10 here, there is a common factor we can divide out because 2 goes into 10 5 times and 2 goes into 2 1. So then multiply across the numerators. 1 times 7 is 7. 9 times 5 is 45. And that is in simplest form. Let's see, number 3. Now, number 3 changes up a little bit. We have addition, and when we write the addition, this is how it's written. You have 1 over 8, let me move this up, plus 9 1/2. Now, the problem with this, because we want to line up the place values, like if you were doing decimals or something, you want to take this and rewrite it vertically. So that would be the same as 1 over 8 plus whole number 9 1/2. Now, look at our denominators. Before you add and subtract, you've got to get a common denominator. And if we look at 2 and 8, the least common multiple between 8 and 2 is 8. So 1/8 will stay the same. We look at 2 and 8. I know that 2 times 4 is 8, so 1 times 4 is 4. So I've renamed 1/2 to 4/8. I'm adding my numerators only. 1 plus 4 is 5 over 8, the original denominator, and then I have 9 plus, there's nothing up here, 0. So that answer should be 9 5/8. Now, I'm trying to explain this as we go through so that you can kind of see and know. Number 4 is a subtraction problem, and we have 1 3/4 minus 4/5. Now, in looking at this, I know that I've got to rename these because notice the denominators are not the same, okay? So between 4 and 5, I know that the common denominator, the least common multiple is going to be 20. And I know 5 times 4 is 20 and 4 times 5 is 20. That's my multiplicative value. So 3 times 5 is 15, and then 4 times 4 is 16. Now, because we only add and subtract the numerators and the denominators stay the same, notice that the 15, excuse me, is smaller than the 16, so I have to regroup here. So I have a whole number here, and whatever I borrow has got to be in 20ths so that I can add that to that. So I'm going to take that 1 away and make it a 0. My 1 needs to be in 20ths, so I know that 1 equals 20 over 20. So I'm going to add that 20 over 20 to what I have. So that would be 35 over 20 minus 16 over 20. So there you go. You see what we have there. Now, I know that 16 times 2 is 32. I have 35, so I know that when I add that up, 5 and 6 is 11. Carry the 1. 3 plus 1 is 4 plus, excuse me, I'm not adding, I'm subtracting. Holy cow, wait just a minute. My brain, let me fix that. Sorry. And this is how easy it is to make just a simple little mistake without being aware. So I'm subtracting. 11 minus 6 is 5. And I had to borrow 1 from there, so that's a 2. 2 minus 1 is 1. So if I look at this, no, that's not right. Hold on. My brain is not working. Let me do this over here. 35 minus 16. Oh, so it should be 15, not 11. That one up there messed me up. So 15 minus 6 is 9. And then 2 minus 1 is 1. So it should be 19 over 20. Sorry about that. Hopefully that didn't mess any of you up. My brain is just warming up. And this is something new. I just got this document camera, so I'm hoping that this will help us. All right, now we're dividing. Number 5. Number 5, let's see, that's that answer. Number 5, I'm dividing. So remember, all division is, when we do 1/2 divided by 3/4, is multiplying by the reciprocal. So if I rewrite this as a division, rewrite this division problem as multiplying by the reciprocal, it's going to be 1/2 times 4/3. Now, when you look at this, you can see I have a common factor here because 2 will go into both of these, so I can divide that out. 2 goes into 4 2 times, 2 goes into 2 1, so we multiply across. 1 times 2 is 2. 1 times 3 is 3, so your answer would be 2/3 for that. Remember, all division is multiplying by the reciprocal. Number 6 is also a division problem. And we have 1/5 divided by 6/7. Now, because we are multiplying by the reciprocal, I always want to rewrite this in my fraction form. So we have 1/5 times 7/6. And if that was a mixed number, we would convert it. I'm looking at what I have. I don't have any common factors here, no common factors here. So we're left with 1 times 7 is 7, and 5 times 6 is 30. 7/30 is your final answer. Oh, sorry, I didn't have that down far enough. Let me see. Number 7. Number 7 was the word problem where it says Lucy cuts a board that is 3/5 of a yard long. And she wants to cut it into pieces that are 3/10 of a yard long. So we want to see how many 3/10 are going to be in this 3/5. So if you think about just the division of it all, we're splitting this. This is our dividend, and 3/10 is our divisor. So we're going to do 3/5 divided by 3/10, which would be 3/5 times 10/3. And if you look, this cancels out. That's 1 and 1, 5 and 10. 5 goes into 10 2 times. So it shows that we'll have 2 boards in that. Now, if I was going to model that, I would do my fifths and tenths over the top of each other. This is not going to be perfect because y'all know I'm not an artist. But if we did this, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to use 3 out of 5, 1, 2, 3 for the original board. So it's not going to go past here. So this we don't need. And then for my tenths, I'm going to have this, and I'm going to have my 5s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, because we're only using 3/5 long, this is my 3 out of 5, 1, 2, 3. I want to see how many sections of 3/10 are in this. So if we just count it over, 1, 2, 3, then 1, 2, 3. So we have 2 sections. So it's the same thing. That's just showing you how we would use the modeling. And again, we wouldn't use this part because we only need 3/5. So there's 2 3/10 sections in 1 3/5. Number 8, moving right along. Number 8, we're dividing, and it says to enter the quotient in the simplest form. So for number 8, we're dividing mixed numbers. We have 7 1/5 divided by 4/5. And so when you look at this problem, before I can do anything, I've got to convert that mixed number to an improper fraction. And then I can multiply by the reciprocal, which would be 5/4. 7 times 5 is 35, plus 1 is 36, over my original denominator of 5, times the reciprocal. I'm going to flip the 4/5 and make it 5/4. Does that make sense? And then I look at what I can cancel out. 5 will divide itself out, and 4 goes into 36 9 times. So 9 times 1 is 9. 1 times 1 is 1. So your answer is 9 for that one on number 8. Number 9. Okay, I like writing this out on here. And you always want to make sure that when you're doing this, you write your answers out on your spiral, not on scratch paper, because in here, we can look back to this and see, okay, this is where I worked out the questions on my test, and we can see exactly what you did. Like up here, when I was looking at this and I kind of mixed up my operation, that is a very common mistake, and we all do it. But when I went back up here and I had to self-correct, I can see where I actually did the operation to come up with the answer, and I would know exactly what I did wrong if I was doing correction. So number 9, we have 1 7/8. Now your numbers are probably going to be similar, but not the same, divided by 2 2/5. Now remember, before I do anything, I've got to convert these into improper fractions. So 1 times 8 is 8, and 8 plus 7 is 15 over the original denominator 8. And then 2 times 5 is 10. 10 plus 2 is 12 over 5. So that's over the original denominator. So that would actually be, as a multiplying by the reciprocal, 15 over 8 times 5/12. Now, in looking at this, my 8 and 5 have no common factors. But if you look at 12 and 15, 3 goes into both of those. So 3 goes into 15 5 times. 3 goes into 12 4 times, and then we multiply across the numerator and denominator. 5 times 5 is 25. 8 times 4 is 32. 32. So I have 25 over 32, and there's no common factor here that I can reduce it anymore, because the factors of 25 are 1 times 25 and 5 times 5, and the factors of 32 are 1 times 32, 2 times 16, and 4 times 8. Okay, so 25 over 32 is the answer for number 9. Number 10, moving right along, just going to go to the back and keep numbering my answers. Number 10. Number 10 is same kind of division problem. We're going to divide a mixed number by a mixed number, 9 1/4, divided by 9 1/2. Now remember, we're dealing with parts of a whole. A fraction is just a part of a whole with a whole number, so we're actually splitting, and we're going to get smaller parts when you divide. So if I convert these, 9 times 4 is 36 plus 1 is 37 over 4. Divided by 9 times 2 is 18, plus 1 is 19 over 2. And if we look at multiplying by the reciprocal, 37 over 4 times 2 over 19. This cancels out. 2 goes into 2 one time, 2 goes into 4 two times. 37 times 1 is 37, and 2 times 19 is 38, so my answer is 37 over 38. Number 11 is the same thing, dividing mixed numbers. So if I start with 8 1/3 divided by 1 3/7, before I do anything, I have to convert these to improper fractions. So 8 times 3 is 24, plus 1 is 25 over 3, divided by 1 times 7 is 7, plus 3 is 10 over 7. Then you multiply by the reciprocal. 25 over 3 times 7 over 10. Now, no common factor between my opposite numerator and denominator here, but if you look at my 25 and my 10, 5 goes into both of them. 5 goes into 10 2 times, 5 goes into 25 5 times, and when we multiply across, 5 times 7 is 35, 3 times 2 is 6. I know that 6 times 6 is 36, so 6 will go into 35 5 times. 6 times 5 is 30, and then 35 minus 30 will be 5 over 6, our original denominator. The main thing is just writing your numbers down, looking for ways that we can reduce our answer before we move ahead, and also following the process. Because really, guys, it doesn't matter. You can do all of these problems. It doesn't matter what the numbers are. You just have to follow the same process. And I know you guys know this. I know you can do this. But we got to pay attention because it is so easy to make common mistakes. Okay, now number 12. This was the one that was the mixed operations, and we are doing the hike. We say Jamal hiked on 2 trails. We know there's 2 trails. We also know that the first trail was 7 1/3 miles, and the second trail, what does it say about the second trail? The second trail was 1 9/11 times as long as the first trail. So 1 9/11 times as long as the first, okay? So what that means is I can figure out what the second trail is by multiplying the first trail times the amount that it was as long. So if I do that, I'm going to multiply the 7 1/3 times the 1 9/11. Now, the question for your problem is, how many miles did Jamal hike? That's with the first trail and the second trail. So after we find out what the second trail is, that's when we're going to add the first trail and the second trail together to get the total miles that he hiked. So the first trail we know is 7 1/3. The second trail is 1 9/11 times as long. So if we do 7 1/3 times 1 9/11, convert your improper fractions to mixed numbers. 7 times 3 is 21, plus 1 is 22 over 3, times 1 times 11 is 11. 11 plus 9 is 20. Yeah. All right. So 11 plus 9 is 20 over 11. So if we look at this, I can kind of cross simplify here. 11 and 22 share the common factor of 11. So 11 goes into 11 1. 11 goes into 22 2 times. And then if I look at this, 2 times 20 is 40. 3 times 1 is 3. And I want to know how many times 3 will go into 40. I know that 3 times 12 is 36. 3 times 13 is 39. So we'll say it goes 13 times. And 40 minus 39 is 1 over 3. So this is the second trail. And I'm not done. So now I have to add the first trail, 7 1/3, plus the second trail, 13 1/3, to get the total. So the first is 7 1/3 plus the second, we just decided, is 13 1/3. I don't have to get a common denominator. Remember, we always adding and subtracting numbers for fractions and decimals, well, any number really, vertically, so we can line up the place values. So I'm lining up my fractions, lining up my whole numbers. I add the numerators. 1 plus 1 is 2 over 3, the original denominator, and 13 plus 7, 7 plus 3 is 10, carry the 1, is 20. So he went total 20 2/3 total miles in all. And that is the answer to number 12. Now, number 13 is a mathematical reasoning question. On number 13, it says, select the description of a real-world situation that is dividing, or that is modeled by dividing two fractions or mixed numbers. So for number 13, basically we need to look at each situation and then decide which ones are not reasonable for dividing. On situation A, it says you have 5 bags of grapes that weigh 3/4 of a pound each, and you want to know how much they weigh all together. Divide 3 3/4 by 5 to find out that the bag weighs 3/4 of a pound. Now, that whole thing of weigh all together, that would mean that you would multiply the number of bags times how much one weighs, not divide. So that is not the choice. For section B, it says you have one bag that weighs 3 3/4 pounds and another that weighs 3/4 of a pound. You want to find the weight of the bags all together. Divide 3 3/4 by 3/4 to find that the bags weigh 5 pounds altogether. That's not the way we would do it either, because it says the weight of the bags altogether. You would add if you're finding the weight altogether, not divide. In part C, it says you want to divide 3 3/4 pounds of grapes into bags that hold 3/4 pounds each. Divide 3 3/4 by 3/4 to find that you can fill 5 bags. Now, that seems to make sense right there, but let's read the last one just to be careful. But I'm going to write down the 3 3/4 divided by 3/4. And they're saying the answer should be 5, but we'll come back to that one. The last answer is D. One grocery store is 3 3/4 mile away, and another is 3/4 of a mile away. You want to find out how much farther the first grocery store is. So you would divide 3 3/4 by 3/4 to find that the store is 5 miles farther away. Okay, so if we're looking at how much farther, we would have to multiply the 3 3/4 times the 3/4. So I think that would not be a viable solution. So let's look at what we have here. 3 3/4, 3 times 4 is 12, 13, 14, 15. I'm just checking my answer. 15 over 4 divided by 3 over 4. And that is 15 over 4 times 4 over 3. That cancels out. 15 and 3 can be, they share a common factor of 3. So 3 goes into 3 one time, 3 goes into 15, 5. Multiply across, 5 times 1 is 5. 1 times 1 is 1. So that is the correct option. So C, dividing the total amount of pounds by how much goes in each bag will give us 5 bags. And that was answer choice C. And that's how we would work those out. Now, I've just kind of worked through the whole process and shown you step by step how we would do this. And I'm hoping that this recorded. We did 13 problems in 23 minutes. So hopefully that will help us as we go through. I'm going to try to stop.